Okay, here's our third video talking about factoring the GCF, and again, I'm still only focusing on GCF. You have to have a good concept of how to determine this before we can actually factor. So we've already talked about GCF of numbers, GCF of variables. Now let's stick them together and talk about polynomials. Okay, so just like the other things, we want to see what, start with just the numbers. What can those numbers be divided by? What do they have in common? Well, 2 can be divided by 2. 6 can be divided by 2. So you're going to divide out of 2. Show what does it look like when I divide by 2? So 2 divided by 2 is 1. I'm just going to leave the x squared. 6 divided by 2 is 3. And then leave the x. Look at just your numbers again. Can those numbers be divided by anything else besides 1? 1 can't be divided by anything else but 1. 3 can only be divided by 1, so you're done with the number. Okay, it's okay to take it steps at a time. Once you get the hang of it, then it'll go a lot faster. You'll get used to it. So now we're going to look at the letters. GCF of the letters, what do they have in common? Well, x squared and x. Remember, that's a 1 when you see no number. So what's the smallest one? Well, x. So that's what you're going to divide out. One thing that you have to remember when you're dividing is you have to subtract the exponents. So x squared divided by x, you subtract the exponent. So 2 minus 1 leaves just an x. Okay, I'm going to leave 3. If I have x to the 1 and I divide by x to the 1, 1 minus 1 is 0, so there are no x's left. So GCF takes both of the things that you divided by. Okay, 2 and x to the first. So that is your GCF. Okay, and it's going to take a little bit of getting used to before you get the hang of it. Okay. I guess I'll stick with purple here. Okay. So again, start with just your numbers, kind of getting a routine of how you work it out, and say what can 6 be divided by? Well, 6 can be divided by 2 because it's even, but 15 can't. 6 can be divided by 3, and so can 15. So we're going to divide 3. They can be divided by 3. So in the parentheses you write, hey, what's left over once I divide by that 3? 6 divided by 3 is 2. Just leave the variables as they are. We'll mess with them in a second. 15 divided by 3 is 5. Leave the variables. Okay? Alright, 2 and 5 can't be divided by anything else, so we're done with those. Now let's focus on the letters. These are both y's. Again, it has to be the same letter. So y to the 5th and y squared. The smallest one is what they have in common. So y squared has 2, y to the 5 has at least 2, so that's what your GCF is, y to the 2nd. So when you put what's left over, you subtract the exponents, 5 minus 2. So that leaves y to the 3rd. 2 minus 2 is 0, so there are no y's left on that term. Okay, there's no other y's in common, and this is what our GCF is made of. So 3 and a y squared. That's the GCF of those two polynomials. Okay, I think I've got 2 more for you. Now this one's tricky because there's no number in front. Okay, but remember when there's no number, it's a 1. So let's put that visual 1 for us. 1 and 7 can't be divided by anything in common other than 1. Now you can go ahead and divide by 1. Nothing's going to change. It's not going to affect it at all. So I'm just going to leave it and not add an extra step for myself. So since they can't be divided by anything else, I'm going to go on to the variables. Okay, you have a to the 4th and a to the 3rd. The smallest one is what they have in common, so you can take out a to the 3rd. Alright, so the visual 1, you can keep it there if you still need it. And to see what's left of your a's, you have to subtract the exponents that you have here. So 4 minus the 3 is 1. Okay, 7 stays 7. 3 minus 3 is 0, so there's no more a's on that term. So the only thing that you took out here is a to the third, and that's your GCF. Okay, last one. A little bit longer of a problem because there's 3. Still works the same way. We have lots of extra letters here, but all you have to know is take it one step at a time. So I'm going to start just with the 3 numbers. 4, 10, and 6. First thing offhand I see is that they're even numbers. Well, even numbers can all be divided by 2. So I'm going to start there. 4 divided by 2 is 2. The variables, I hate when it does that. Hang on. Sorry. I hate to add time to your thing, but I don't want to have to start it all over again. Alright, so bring down the variables as they were. 10 divided by 2 is 5. Bring down the letters and their exponents. 6 divided by 2 is 3. Bring down the letters. Double check your numbers, 2, 5, and 3. If they can be divided again, you need to divide them again. But in this case, they can't. So when you have more than one letter, I go alphabetical, so I'm going to start with A's. So I'm looking for the smallest exponent, which this one doesn't have one, so it's a 1. The smallest one is what they have in common. That's its GCF. So the only thing I can take out is an A. So I'm going to leave the 2. And remember, that's a to the 1. So to see what a you put down here, you have to subtract these exponents. 2 minus 1 is 1, so I still have an a left. Bring down the b's. We haven't done anything with those yet. Okay, your exponent here is 4. 4 minus 1 is 3. So we're going to put a to the third. Bring down your b's. 3. 1 minus 1 is nothing, so there's no a left. So I'm just going to bring down the b that I have. Okay, so there's no other a's that all 3 have to have. All 3 have to have them. Even though these 2 have a's, I can't because that one doesn't have a. So the last one is b. Okay, the smallest b they have in common is 2. So that's what I'm going to put out here. Okay, so the 2a still comes down. 3 minus 2 is 1. So you just still have a b. A to the third stays. b2, so 2 minus 2 is nothing, so there's no b left here. The third term, you have a 5, so 5 minus 2 is 3, so that makes b to the 3. Double check. They all 3 have to keep going. So we're done. We're going to check our GCF now. So 2 and a to the 1, you don't have to put the 1, and b squared. So that is the GCF of these 3 monomials.